Good morning to all. I am Karina from BSc Chemistry Honors final year. Today's our chapter is from Pradeep's Organic Chemistry book by Dr. S.N. Dhawan. Our topic is steroids. Introduction. Steroids are a group of structurally related compounds which are widely distributed in animals and plants. These include sterols, vitamin D, bile acid, a number of sex hormones, and adrenal cortex hormones. The structures of these steroids are based upon 1,2-cyclopentanopenanthine nucleus. In fact, a steroid may be defined as any compound which gives, among other products, dialed hydrocarbon 3-methyl cyclopentanopenanthine on dehydrogenation with selenium at 633 Kelvin or 360 degrees Celsius. However, if the dehydrogenation is carried out at a higher temperature, that is 693 Kelvin, 420 degrees Celsius temperature, steroids mainly give chrysin along with a small amount of piquine. As shown above, dialed hydrocarbon, chrysin and piquine are all polynuclear aromatic hydrocarbons. Classification of steroids. Some important classes of steroids, along with their representative examples, are briefly described below. Sterols. Sterols are crystalline compounds and contain one alcoholic group. They occur in animal and plant oils and fats, either free or as esters of higher fatty acids. They are broadly classified into three categories: zoosterols. Sterols which are obtained from animal sources are called zoosterols. For example, cholesterol, cholestanol, 5-alpha cholesterol, 3-beta ol, and coprostanol, 5-beta cholesten, 3-beta ol. The structures of these compounds are given below as we can see. Phytosterols. Sterols which are obtained from plants are called phytosterols. For example, stigmasterol and beta-sitosterol. Mycosterols. Sterols which are obtained from yeast and fungi are called mycosterols. For example, ergosterol. This classification is however not rigid since some sterols are obtained from more than one source. Cholesterol. C27 H46O. This is the sterol of higher animals. It occurs either free or as fatty esters in all animal cells, particularly in the brain and spinal cord. It was first isolated from human gallstones, which consist almost entirely of cholesterol. The main sources of cholesterol are the fish liver oils and the brain and spinal cord of the cattle. Lanolin, the fat from wool, is a mixture of cholesterol, palmitate, stearate, and oleate. It is also present in significant quantities in egg yolk. Cholesterol is a white crystalline solid, melting point 422 Kelvin, 149 degrees Celsius. It is optically active and its angle is given as 39 degree. In fact, cholesterol has 8 chiral carbon atoms: 3, 8, 9, 10, 13, 14, 17, and 20, and hence has 2 raised to power 8 equals to 256 stereoisomers, and cholesterol is one of these. Look at the structure of cholesterol. It consists of a side chain containing 8 carbons, a nucleus containing 19 carbon atoms. The nucleus consists of 4 rings designated as A, B, C, and D. Beginning from the 6-membered ring on the left, the nucleus also contains 2 angular methyl groups at C10 and C13. Vitamin D. Vitamin D is also called antirachitic vitamin. It is essential for bone formation. It also controls the calcium and phosphorus metabolism. Vitamin D, more precisely vitamin D2, was obtained by photochemical irradiation of ergosterol. Thus, ergosterol is pro-vitamin D2. Vitamin D2 is also called ergocalciferol. Bile acids. Bile is a secretion of the liver and is stored in the gallbladder. The bile acids occur in the bile of most of animals as amides with either glycine or taurine. The bile acids occur as sodium salts and they act as emulsifying agents in the intestinal tract. In other words, fats which are insoluble in water are rendered soluble by bile acids which emulsify them. As a result, fats are absorbed in the intestine. Most of the bile acids are hydroxy derivatives of either 5-beta cholinic acid or 5-alpha cholinic acid. About 20 natural bile acids have been characterized and many others are synthetic. The positions of the hydroxyl groups are any of the following: 3, 6, 7, 11, 12, and 23. Adding almost in all of the natural bile acids, the configuration of the hydroxyl groups are alpha. Some of the important bile acids are cholic acid, position of hydroxyl group 3 alpha, 7 alpha, 12 alpha. Source is man ox. Deoxycholic acid 3 alpha, 12 alpha. Man fox. Lithocholic acid 3 alpha. Man ox. Chinodeoxycholic acid 3 alpha, 7 alpha. Man ox hen. Alpha hydroxycholic acid 3 alpha, 6 alpha, pig. The structure of the three most important bile acids are cholic acid 3 alpha, 7 alpha, 12 alpha, trihydroxy 5 beta cholinic acid. Deoxycholic acid 3 alpha, 12 alpha, dihydroxy 5 beta cholinic acid. Lithocholic acid 3 alpha hydroxy 5 beta cholinic acid. Sex hormones. Hormones are organic substances secreted by endocrine ductless glands acting at a site other than that of their origin. They are required in very little amounts for their physiological functions in the body. Classification. Although the hormones are not related chemically, they can be grouped together on the basis of their similar physiological activities. About 80 such compounds are known, of which a about half have a steroid nucleus while the other half are non-steroidal in character. Steroidal hormones are of two types: sex hormones and adrenocortical hormones. Sex hormones are steroids which are responsible for primary sexual processes and secondary characteristics such as voice, hair, texture of skin, etc., which differentiate males from females. They are produced in gonads, testes in the males, and ovaries in the females. Sex hormones are of the following three types: oestrogens. Oestrogens are the female sex hormones which control the menstrual cycle in women. Representative of examples are oestrogen, oestradiol, 17 beta, oestriol. Androgens are male sex hormones. Important examples are testosterone, androsterone. Gastrogens are the hormones of corpus luteum, a tissue of the ovary colored yellow by carotene. These are responsible for maintenance of pregnancy. Representative examples are progesterone, prognanediol. Adrenocortical hormones. These are produced in the cortex of the adrenal glands. These are 29 in numbers and are collectively referred to as corticoids. Corticoids have many physiological functions, but their main functions are the carbohydrate and the protein metabolism and the control of balance of water and electrolytes. Some important examples are cortisone, corticosterone, 11-deoxycorticosterone. Thank you.